Well, hello and welcome back, pre-AP chemistry students from Allen High School and anybody else who has stumbled across this video series. Welcome. We are going to apply the calculation of a mole ratio to get a formula. That's what we did with empirical formulas from given experimental data. But instead of getting a molecule or a molecular or a formula unit ratio, we're going to apply this to hydrates. The concept is so very similar. In fact, it's one step less than what we had before. If you'll remember, for our other empirical formula, we had percent to mass, and you may have to do that, and we're going to do that the same way. If we have percent to mass, you're going to assume 100 grams. Mass to moles, whoops, a little bit too many there. Mass to moles. You always will have to do that, sometimes do that. Divide by the smallest, and that's it. You will never multiply by a whole number on hydrates. So remember, it was multiply till whole. On a hydrate, we never, there are a few you might see like that in the world, but we will never see those. We are never going to be multiplying to whole for a hydrate, and I'll show you why. We have a hydrated iron 3 nitrate. So I've got Fe, don't like that blue so much against the gray, FeNO3 dot some number of waters. At our level, we are always going to have one of the salt to some number of waters. And 1 to X is a mole ratio. I mean, it could be a formula unit molecule, but we're past that now. We're focusing exclusively for a while on these, not exclusively, okay, primarily on mole ratios. So instead of finding subscripts, we're finding this mole ratio. But it's the same thing. You got to get mass to moles to get a mole ratio, and you have to divide by the smallest to get the ratio. Now, in this case, the salt will always be the smallest because that's the one. It's always one salt to a whole number of waters. I've seen a half before, but you will not see a half there. So your little sing-songy phrase, percent to mass, mass to moles, divide by the salt. It kind of falls dead on us there, or falls flat might be better. All right, let me show you what I think is, there's a couple of good ways to set this up, but I'm going to try this year. Let's set it up how we did it before in our spreadsheet. We have FeNO3 and we have water. Now, percent to mass, we don't need to do because it gave us the mass of our substance. So we didn't need to do the percent part. Now, we are given two values, and you have to be really careful with your wording here. You see that we have the hydrated iron 3 nitrate. That means the iron 3 nitrate with its water is 300 grams. Hydrated means with water. So this mass plus this mass, the total mass is 300 grams. Now, we heat it up, we drive off the water, and we'll be doing this in lab. And you find that the anhydrous, that means the without water portion. That's my anhydrate portion, is 179.7. So what you can do is by subtraction determine that water, right, because the anhydrate plus the water equals the hydrate. So I can determine this via subtraction, 300 minus 179, and I get 120.3 grams. So to get that number, I took 300 minus 179.7, because that sum had to equal the whole hydrate, right? So, a little tricky. I can show you another way in class if you want me to. There's a variety of ways to do that part. Okay, percent to mass. Now we want to go mass to moles. It's the same. Mass to moles, use molar mass. So we have grams, we want to eliminate grams, but instead of molar mass of an element, I'm going to use molar mass of water. I have grams of water, I use molar mass of water. That's 18.02 grams. And 1 mole of iron 3 nitrate, I'm assuming you can calculate, is 241.86 grams, right? 1 iron, 3 nitrogens, 9 oxygens. Percent to mass, didn't need to do. Mass to moles. And our next step is identical, divide by the smallest. Now, I'll tell you, if your salt is not your smallest, we have a big problem. You need to go back and rework some of your algebra. So, percent to mass, mass to moles, divide by the salt. Never multiply till whole this time. Just on your hydrates. And you better, again, here, come up with pretty darn close to a whole number, or there's an algebra issue involved, right? So let's take a look. If we did that, we get 1, which of course we expected to get, and we get a 9 here. So what that means is that the formula of our hydrate, we now know the X, or the number of waters in our hydrate. You need to know how to be able to name these. We've done them before. We have iron 3 nitrate. Well, that was given at the beginning, so we pretty much gave you the salt there. Now, I have to tell you how many waters. Remember, if you're dehydrated, you drink water. Well, that's a hydrate. And I need to tell you how many, and we use a prefix nona to tell you. So that's iron 3 nitrate, nona, hydrate. Let's do one more of these, just so you can get a sense of different ways they're worded. So I have iron 2 sulfite. So I have Fe, irons plus 2, sulfites minus 2, dot some number of waters. I know that's going to be a 1. I need to find the X. So let's set up our little spreadsheet. We have our FeSO3, and we have our water. Substances that are compound in water, molecule instead of elements. Other than that, it's just like an empirical formula. So percent to mass. Well, we have 44.26% water. Remember, the simplest assumption is to assume 100 grams. So I'm going to assume that I have 100 grams total of my hydrate. 44.26% of that is water. So I have 44.26 grams of water. That means I need to solve for my amount of FeSO3. But I should just be able to get that by subtraction, right? 100 minus 44.26 gives me 55.75. Now, if you're not getting these things, it'd be a good idea to write them down. Some teachers have Google documents for you to write your questions into, and I'm kind of thinking of doing that. Okay, I don't really want to use that color because I used it on the addition. So let me clarify that a little bit. Now we're going to do a dimensional analysis. Percent to mass, mass to moles. Mass to moles, use molar mass. So I've got grams of water, 18.02 for every 1 mole. And you need to be able to determine the molar mass of iron 2 sulfite. So you might want to pause the video when times like that come and calculate it yourself. I love when people redo my calculations. I make algebra errors just like y'all do. And I would hope you would try to catch those for me. Sometimes I think I should purposely embed them to see who finds them and be like, where's Waldo? Where's Dr. Leggett's mess up? So you can say out loud, oh, Dina. Okay, so I get 2.456 moles of water and 0.4102. Don't round. It's just like what we did before. You want at least 4 values. Remember, if you didn't get the salt to be the smallest, we have a problem here. And you need to go back and look at your algebra. 0.4102, because of course that should be 1. And 0.4102 gives me 6 for water. A 6. So my formula is FeSO3.6H2O. You will be asked to name this on your test in the free response. So it's iron 2 sulfite, hexa for 6, hydrate for water. Wow, that's the end of this unit. Fantastic, great perseverance. I hope we get great productive time in class. Until then, this is signing off.